Hey everybody, welcome to today's lesson. It's on problem solving with angles, which we've been working on. And for today, this is a culminating lesson. And what I'm doing today is I am taking some problems from the Ready book. But I want you to know that I'm not expecting you to solve these. I'm going to want you to take notes today on what I did to solve them. Of course, if you want to challenge yourself, what you could do is try solving the problems before I do, but just know that's not the expectation. I just want you to take a look at what I did, and I'll ask you to take some notes on it. Okay, so you can see today's target involves using what we did on Tuesday, which was combining like terms and solving for variables to solve for missing angles and find the value of specific variables in geometry problems involving angles. I found this image here of some of the things that we're going to be using today. We're going to be using the idea of vertical angles. I'm going to introduce the term congruent to you in a slide. Remember, adjacent angles are right next to each other. One way I remember adjacent is just by thinking about that in everyday uses. Like I would say I live adjacent to a 3-story apartment building. That just means next to. So adjacent angles are just right next to each other. We're also going to use complementary and supplementary angles. Here's a term for you, linear pair. That's just two angles that are together that form a straight line. So you can see actually over here at the supplementary angle, those also could be considered a linear pair. All right, so let's take a look at the first of 3 problems that we're going to work on today. This comes from page 180 in your Ready instructional booklet. And you can see you've got a picture there of a quadrilateral. This is actually what we would call a trapezoid. So it doesn't really matter how you state the letters. I'm going to call it trapezoid A, B, C, D. The only thing is you just must state them in order. A trapezoid has 2 parallel lines. So BC is parallel to AD. So we've got this quadrilateral, and then we've got 2 of the line segments extended into rays on that quadrilateral. So segment AD is now extended to ray AE, and segment CD is now extended to ray CF. Our goal is to find the measure of angle ADC. All right, so I'm hoping some of you have already noticed a few things there. First of all, angle ADC is vertical to angle EDF. So I know whatever this angle measurement is going to be the same as this one here. All right, so I'm going to use this fact here. Ray CF makes a straight angle here. If you add angle CDE and angle EDF, you're going to have 180 degrees. Right, so I've written this right here. This small m means measure, so the measure of angle CDE plus the measure of angle EDF is going to equal 180. All right, so what I'm going to do is just substitute the expression in for each then. So 2x1 plus x minus 7 equals 180. All right, so that's the geometry piece of that, a little bit of algebra. All right, but let's take a look at the next slide where I'm going to start doing the algebra. I want you to remember that in situations like this, before you try to solve for the variables, you should always combine like terms. Another way of saying that is simplify it as much as possible. All right, so I can see my like terms here are the 2x and x. Remember, that's the same as 1x. So that gives me 3x. And then I have a 1 and a negative 7. Well, when I combine a positive 1 with a negative 7, that gives me a total of negative 6. So 3x minus 6 is equal to 180. Now that we've got it simplified, we can solve for the variable. All right, so I'm starting right here. I want to isolate the variable. We talked about that a little bit on Tuesday. That means I want to leave the x by itself. So I basically want to get rid of everything that's on the same side of the equation with the x. All right, let me state that again. Listen to what I just said. I want to isolate the x, so that means I want to get rid of everything that's on the same side of the equal sign with the x. So I want to get rid of the negative 6, and I want to get rid of the 3. And then by doing that, I'm isolating the variable. I do that by doing the opposite of whatever is in the equation, right? So I can look at this in 2 ways. I can say it's minus 6, so I'll add 6, or I can say it's negative 6, so I'm going to combine it with a positive 6. Either way, whatever way you think about that, it's going to be the same. So I'm going to combine positive 6 on both sides of the equation. So I end up with 3x is equal to 186. All right, then the last step down here is 3x is a multiplication problem. So I want to divide. So I'm dividing both sides by 3, which leaves me with x equals 62. All right, so we're done, right? Right? A lot of people, when they start doing algebra or applying algebra, they stop as soon as they know what the variable is. But as we know, that was not the question. We were asked to find out the measure of angle ADC, right? And we know that that's going to be the same as angle EDF, which is equal to x minus 7. So you can see right here, the measure of ADC must be equal to x minus 7. So since x is 62, then x minus 7 is going to be the same as 62 minus 7. So it's going to be 55. So then you can see by that bottom line there, then the measure of angle ADC is 55 degrees. All right, that's the end of the first one. Let's take a look at the second problem. Okay, so you can see in this problem that we're going to actually use complementary angles. If you look at the instructions at the top, this problem comes from 182 in your instructional booklet, and you can see right here you have a rectangle. Since this is a rectangle, I know right away that all 4 corners are right angles, which means all 4 corners are 90 degrees. That's in the definition of a rectangle, same as a square, that all 4 angles are right angles. Okay, so here's what I know then. If you look down at the bottom, I know then that the measure of LKM plus the measure of MKN is equal to 90 degrees, which means angle X plus angle X plus 14 must equal 90. So what I'm going to do is solve for X, because here's what I'm looking for. PKQ, well, I know that is vertical to this one here, which is X plus 14. So I know that PKQ must also be X plus 14. So I need to figure out what that X is. Okay, already well on my way because I've already combined like terms. Okay, so down here is the new part. I'm going to solve for the variable now. So I'm going to start by combining negative 14 on both sides. And when I do that, I end up with 2x equals 76. Then my next step here, you can see by looking down here, is to divide both sides by 2. So I have x equals 38, right? Well, now I'm going to be able to do this, right? Since x is equal to 38, and I know that the measure of angle PKQ is equal to the measure of angle NKM, then I can just substitute it in. I'm going to talk more about these 3 dots, and I'm going to talk more about this symbol on the next slide, but this is how I would say this. Therefore, the measure of angle NKM is equal to x plus 14, which is equal to 38 plus 14, which is equal to 52. Note I wrote that a little bit differently on this slide. I'm just trying to get you used to different ways of writing your math problems out. So that's just another way to do it. So the measure of angle NKM then is 52 degrees. Okay, so right here, this symbol right here that's an equal sign with a squiggly above it means congruent. And in geometry, if 2 shapes, could be angles, it could be triangles, any shapes. If 2 shapes are exactly the same, we call them congruent. It's kind of like equal, but it's for shapes. So this tells me that angle PKQ is congruent to angle NKM. I should have a little angle symbol in front of those, right? But look over here. If we're talking about the measurement, since measurement involves a number, we use an equal sign. So if we're talking about the shapes, we use congruent. If we're talking about anything that's involved with a number, we use equal. All right, so I'm hoping that makes sense. This symbol is something that we'll be working with later, but I thought this was a good time to introduce it. These three little dots here are often used in math and science, and those three dots just mean therefore. So basically, I say the measurement of angle PKQ is equal to the measurement of angle NKM. Therefore, the measurement of angle NKM is equal to x plus 14. Right, so this is just a good one to know, and it's going to come up for you frequently in your future math classes. All right, last problem for this slideshow. This is problem number 3. It comes from page 184 in your Ready instructional booklet. It's part of the guided practice. And what you need to do here is just find the value of x. Right? You don't actually have to figure out these angle measurements, but you just have to figure out x, although we could figure out the angle measurements if we need to, but that's not what we are asked to do. We're just asked to figure out the value of x. All right, so I'm using again basically the idea of supplementary angles. In this case, these 3 angles are actually supplementary. So when we add all 3 of them, we get 180. So I already combined like terms. Right? We have a 4x and a negative x, so that gives me 3x. I added these together in my head. All right, so I started with 34 plus 76. I often start with my positives. That gives me 110. And then I combine a negative 8 with it, so I just subtracted 10 to give me 100 and then added 2 back in. So what I have here is 3x plus 102 equals 180. All right, you can see now I'm solving for the variable by subtracting 102 from both sides. I get 3x equals 78. And you can see right here, I'm dividing both sides by 3. I'm trying to do the opposite. I want to just be left with the x. I mean, again, it's isolating the variable. So I'm left with x equals 26. And that's it. We're done. We don't actually have to figure out these angles, so we can stop here. All right, I'm hoping this makes sense to you. What I'm going to ask you to do is let's just take a look at this. Did we meet our target today? Students will use combining like terms and solving for variables to solve for missing angles and to find the value of specific variables in geometry problems involving angles. I'd say we did. We learned a little bit about the term congruent, angles with the same measure, exactly the same is another way of putting it. We learned about the symbol for therefore, and we learned about a linear pair. All right, nice work today, everybody. Just fill out the Google Doc that goes with this, and you'll get a meets.